Hi guys, in this video I'm going to go over the properties of parallelograms, and I am going to do partner A's examples, and your assignment is to do partner B's examples. So in every parallelogram, opposite sides are parallel, but they are also congruent, which means they equal each other. Diagonals bisect each other, which means they cut themselves in half. Basically, each diagonal cuts the other one in half. When angles are alternate interior angles, like angle 1 and 2, they are congruent. I can always identify alternate interior angles by a Z shape or an N shape. The angles that are in the corners are congruent to each other. So when we know two segments or two angles are equal to each other, we set them up segment 1 equals segment 2 or angle 1 equals angle 2. So see if you can move these where they belong in the picture of our parallelogram. So the 20 degrees would be an alternate interior angle to that angle, angle ACD. 16, I have one side that's 16, so the opposite side is 16. 10 is a piece of my diagonal, so the other half of the diagonal is 10. M is the midpoint of the two diagonals. And then if one side is 43, I have the other side is also equal to 43. All right, a few more properties of the angles. Opposite angles, like angle 3 and angle 5. Those are opposite because they are in opposite corners of the parallelogram. Opposite angles are congruent, which means equal. Opposite angles are equal. Consecutive angles, consecutive are the ones that are side by side. They share a side. So angle 3 and angle 4 are consecutive angles. 4 and 5 are also consecutive angles because they share this side. So 3 and 4 share this side, 4 and 5 share this side. And consecutive angles add up to 180 degrees. For some reason, my laptop isn't letting me do the thing to make the degree symbol. So if I know that angle 3 equals 20 degrees, then angle 5 equals 20 degrees. Angle 4 has to be 160 degrees because they need to add up to 180. And this empty corner is also 160 degrees because it's opposite from the 4. All right, so the rest of these examples are using those properties to set up equations and solve for a missing variable or a missing side. So if you notice, your partner B example is very similar to the one that I'm going to work through for partner A. So partner A, I have two sides. I know those two sides are opposite, and if they're opposite, they are equal. So I'm going to set up my equation. One side, which is 9x minus 43, equals the other side, 3x plus 29. From here, I would go ahead and solve for x. I don't have a calculator next to me, and mental math is going to take me a long time. So I'm just going to upload the answers separately. But that's the way you set it up. All right, moving on to example 2. This is going to be very similar. If you notice these examples, I have two sides, and they are opposite sides. Opposite sides are equal. So to solve for x, I'm going to set up one side, 15x minus 19, equals 11x minus 3. And I will go ahead and solve this equation from here. All right, question number 3. Anytime you see a picture like this, it's probably about the diagonals. So JN is a piece of the diagonal JL, and NL is the other piece. Well, I know that those two are equal to each other because if JL and KM are diagonals, then N is the midpoint. Where they intersect, it cuts them in half. So since Jn is 1/2, the 14x minus 17 has to equal the other half, 3x plus 38. All right, and again, I would go through and solve that one for x. All right, another picture where it looks like I have something to do with the diagonals. So QT is a piece of one diagonal, and then QS is the entire diagonal. So keep in mind, it does not make sense for you to tell me that 1/2 of the diagonal is equal to the whole diagonal. That doesn't make sense. Half of something can't equal all of something. But I do know that TS and QT are the same. So from Q to T is 4x plus 10. That means from T to S is also 4x plus 10. And when I put those two together, that will be the same thing as QS. So 4x plus 10, sorry if you can hear that, my dog just walked into the baby toy. So those two pieces put together are equal to the entire diagonal QS. So I would combine like terms and solve for x. All right, question number 6, I have angles. Be mindful, all of the other examples so far have had to do with line segments. I could tell that they had to do with line segments because I didn't see the degree symbol at all. But I could also tell because the letters that they used 2 letters to signify that it's a line segment. These you can clearly see are about the angles. And in this case, I have a pair of opposite angles. Opposite angles are equal to each other. So 5x plus 13 equals 9x minus 31. All right, and in the last example, these two are both angles, but they are consecutive angles. They share a side. Consecutive angles add up to 180 degrees. So I would combine like terms and get x by itself. All right, so you should go through and do the example B for the rest of the examples, and I will upload my work for example A. So you will know that you are correct if your answer is the same as the answer that I got for partner A's column.